in spatial data, an area that offers powerful tools for analyzing spatial structures and patterns. Did you know that mathematical morphology originated in the 1960s and uses structuring elements to measure and extract corresponding objects in images? This technique is widely applied in geoscience and remote sensing due to its ability to handle complex data formats. This session will provide a wonderful opportunity to understand mathematical morphology in spatial data, a field critical to image processing and spatial analysis. We are fortunate to have the presence of a very dynamic guest speaker who will help us gain a better understanding on this subject. Now I request the head of the Department of CSE AI and ML, Dr. N. Anusha ma'am, to come over onto the dais. Welcome ma'am. Thank you ma'am. Now I request the principal, Dr. E. Sai Reddy sir, to come over onto the dais. Welcome sir. Now I request co-coordinator of Atal FDP, Dr. Hepsi ma'am, to come over onto the dais. Now I request our guest speaker, Dr. K. Ramohan Rao sir, to come over onto the dais. With that being said, it is time we introduce our speaker of the day, Mr. K. Ramohan Rao from the National Remote Sensing Center, ISRO, Hyderabad. He is currently leading several key projects at ISRO's National Remote Sensing Center with groundbreaking contributions as a head in Application Software and Computing Infrastructure Division, RSSA. Mr. Rao brings with him vast experience in the field of remote sensing, geospatial technologies and spatial data analysis. Mr. Rao possesses a diverse and extensive skill set with expertise in database design, web applications, web GIS, Landsat analysis and numerous other areas. His extensive knowledge and experience make him a valuable asset in these fields. Without further delay, it is my pleasure to invite Mr. K. Ramohan Rao onto the dais to lead us through this insightful session on mathematical morphology in spatial data. Can we please have a huge round of applause?
Before Dr. Ramohan will take over the things, I just thought of thanking him for sparing his time. And yesterday you have seen the surveys who give the data, but he is the person who is a computer science expert, explaining you the processing of data, how it could be done, and related parameters and software linked to that. So I think it will go informative how you are processing the data. That is where it is required. Ocean of data is available. How to process and synthesize is going to explain to that. I hope you will have a more useful session today. Thank you.
morning. Good morning, all of you. Yeah. You can occupy the front seats. Yeah. Yeah. Good morning, all of you. Once again. First of all, let me thank the management of the college, especially Principal Sir and Anisha Madam, to invite here and then giving this opportunity for discussing the spatial data analysis, mathematical morphology, handling of geospatial data, right? So there are so many aspects in the present the topic. So I hope all of you are familiar with the databases, right? How many of you are familiar with the spatial databases or databases, database management systems especially? Okay. So nowadays you are having many discussions or many disciplines in data science, data analytics, data management, and then data warehousing. So there are many data related disciplines actually. So ultimately we are just taking the fundamentals of the database management systems, and then further it is the way of handling the data in a variety of environments. So how do we handle this data? How do we handle this information? What are the topological structures of this data? So the mathematical morphology is nothing but understanding the data elements, understanding the spatial topologies, understanding the data, the properties, parameters, all these things will come under the mathematical morphology. So in this topic, I will be taking you to the dimension of the spatial data. Okay, spatial data and mathematical morphology in spatial data. Okay, so that kind of the topic we are going to look into, and then how many of you are also now? Yesterday I think you have a very precise lecture on the geospatial technologies. So hope you understood the spatial data concept. Okay, so now let us see what is spatial data, non-spatial data. Then with this the brief background, we will go ahead into the lecture in the mode. Okay, can anybody define what is the spatial data? Yesterday we had a lecture on the geospatial technologies, I think, right? Spatial data generally any point, any feature or the data set which is dealing with the positional values or positional values of the earth, that is called as a spatial data. For example, presently we have the college as a point on the map. Okay, what is that map is describing? What is the point is describing to make the spatial data? The spatial data, to become a spatial data, the college point should have the latitude and longitude, horizontal information and vertical. So that is called as a positional information. Any feature that is having a positional information, maybe a road or a point or a polygon, anything. Okay, the property is nothing but a spatial property. So that kind of information, latitude, longitude plus elevation is additional information. You know elevation? Elevation is the height of the distance from the mean sea level. Reference is mean sea level, not the earth. Okay? So that is what the spatial data definition. What is non-spatial data? who is not having a spatial information. Suppose myself, I am a Rama. I do not have any positional values. I am a free data. Suppose employees, all employees are not having their employee number, employee names, employee parameters, etc. But they are nothing to deal with the positional values of the text. But whereas the college is having the permanent tagging with reference to the positional values of the text. Right? Got this difference? So now point is, we are discussing more on the spatial data. Right? So with this spatial data concept, with this knowing the spatial data as one of the parameters for geospatial referencing. So what this spatial modeling describes? Spatial modeling also a phenomena by identifying variables and then significant to the distribution or providing information to the weight and the variable. So the spatial modeling will describe the model composition plus how the model is behaving when this is calibrated. How the model is behaving with reference to the data. How the model is computing the values when you are giving the inputs, variety of inputs, okay, and then how this model is accurate, how this model is depending on the spatial variables accuracy. So the model is individual but the inputs are the parameters. So when your model is calibrating, when your model is, you are changing your model. So the model itself is one of the important describing your phenomenon. So how do you create a model? Suppose you have a model, A plus B. A is a parameter, B is another parameter, and then plus addition is an operator. So that may be one model. Similarly, if you want to critique or you want to have interpolation as a model, or a sum of the quadratic equation. So all these things will combine to a model. So model behavior changes when you have the inputs of a diversified parameters. When you have a diversified inputs, when you have a satellite imagery as one of the input, when you have a GIS file as one of the input, when you have a different the algorithm as one of the input, so the result will vary. So how results are accurate, how results are suitable for your the process, that kind of information is called as the spatial model. So now integration, how do we do this integration? As I told, simple equation C equal to A plus B. How do you integrate the data inputs? Say for example A one of the input, B one of the input. How do you integrate these models? How do you integrate this data? So this is one of the challenging tasks to develop your spatial data integration, and then so the ability is to combine the data using variety of functions, variety of parameters, and variety of the data sets. Okay, C and A and B may not be of the same type. For example, parameter A may be integer, parameter B may be a real one, a real parameters or some other parameter. So how do you combine these A and B? Because A is a different parameter, B is a different parameter. How do you integrate these two parameters to form an addition? So this is the ability of the integration mechanism. So when you have the integration of the individual parameter and then you combine them into a real-time the operation, then that will become a valid algorithm. Okay, what is algorithm? Algorithm is nothing but we have a sequential process of steps or sequential process of the individual components. So when we have the individual components are talking to each other, so that is the process of integration. Okay, you have some complex algorithm, you may be having some 10 variables. So all these 10 variables, when they are not talking to each other, your model will not work, your algorithm will not work. To work your algorithm, what you need to do is integrate all these 10 inputs, 10 variables in a systematic way through a database or through a independent variables or from a schedulers, okay, all these things will form a independent or a combined way of dealing with the spatial data. So the integration of the data to a particular algorithm will form a basis for your application. Okay, somebody can maybe after some time when you are doing some developmental tasks. So for example in the Google also, Google Maps. So reaching from a point to point. Okay, suppose I want to reach from this place to Secunderabad. So we have a Google map. Behind that there is an algorithm. What is the suitable path? Okay, or the optimal path. Okay, what is the shortest path? So these are all the algorithms. I think you are all studying the algorithms. So these algorithms will form a basis to reach from source to destination. There may be many parameters. Distance is one parameter. Road should exist. Okay, from this place to the airport, road exists. Right? Then only it will calculate the distance. Second parameter is the traffic. I want a optimal path, not the shortest. I want to reach fast. So what is the underlying parameter? Traffic. Traffic is measured by the number of vehicles per meter, number of vehicles per kilometers. So the algorithm is simple. Algorithm is point to source to destination, the route. If I am taking a shortest route, that is the distance is the parameter. If I am moving, I want to take an optimal path, distance plus the traffic or width of the road or density of the road or sometimes density of the traffic, number of vehicles, okay, how long this is sustaining for delivery. So all these things are different parameters which are called as dynamic parameters. Distance is static. Static means constant, it will not change. But dynamic parameters are different. Dynamic parameters are nothing but the variables which are changing from time to time. Sometimes maybe 3 vehicles, sometimes maybe 10 vehicles. So that's why always the decision support is changing from time to time. So the process of integration of these information into a single algorithm called as spatial data modeling and integration. Now, I think these details I will rush very easily. Yesterday we have a lecture on the GIS, I think, yeah? So they have told about what is GIS, what is remote sensing, what is GPS, right? So GIS nothing but is a integrated computer based system which are having 5 components: hardware, software, coupled with the data. Data is nothing but spatial data, non-spatial data, and also the procedures. And important thing is are the clinical manpower. So these 5 components will form a GIS for the basis. Now the definition of the GIS has changed from time to time, and then slowly the advancements in the computer science, especially the DBMS, the WebGIS or web analytics or the database manipulations, so that led into the concept called as geoinformatics. So the much more advancements in the computer science has changed the GIS into geoinformatics by the way of handling the spatial data. Okay, it is nothing but capturing the data, analyzing, providing the output, and then dissemination. So geoinformatics is the discipline of handling the spatial data more effectively for the decision making. So ultimately what we are doing, all the data we are assimilating, all the data we are capturing, but ultimately what we are doing is we are doing the analysis as per the requirement of the user. Is it not? That's what the software engineering definition. The software engineering definition is nothing but, I think most of you have heard about software engineering. Okay, software engineering nothing but development of a reliable software products within the cost estimates and the given time limits. Okay, this is what we learned in the software engineering. So we should able to develop the software products or the required products of the user within the time limits and cost estimates by the, we use many software development paradigms. Okay, there are many more engineering models. So similarly, GIS also will have all these important, you see, all these data sources, okay, and then the integration, and then the analysis, and finally what we do is a product required from the user. So GIS can store many different types of the data. Somebody can store satellite imagery, GIS can store a DBMS or a database structure, and it can store some spreadsheet. Okay, so the ability of GIS is it can accommodate all these data sets and can integrate into the GIS field. So this is a simple process. We have this is the GIS layers. Okay, looks like GIS layers. So this is one road layer. This is some vegetation. This is some water body, and this is some collection. So this is the real-time the earth feature. So this real-time earth feature segregated into different layers. Okay, what GIS do is, the property of GIS, you have to segregate the layers as per your topology. Say for example, land is land cover. Land is land cover will give you the information about how the land use is being used. Similarly, road information, transport network. Transport network will give you the information of the road network, connectivity, point-to-point connectivity. All these information will have a this is called as transport. So when you are doing the processing of this entire layers, where you will create the functions. This is called as function. The map is this is what the algorithm sometimes. Algorithm or function are a model, mathematical model. All are almost equivalent. So this is up to you to define what kind of mathematical the application you are building, what kind of algorithm you are building, what kind of functions you are imposing on the functions. So this is nothing but your spatial data modeling. Now let us see one more slide in the spatial data. The concept of spatial data is, here you have seen, what is this? This is a earth feature. Earth is having this road network, the water body here, and some vegetation here, and you see the elevation also. Elevation is not a flat. Elevation is not, it's surface. Surface is not flat. The terrain is undulating. Okay, here the elevation is more, height is less here. So the real-time feature, what we are doing is, we are capturing the information into, we can capture the information into point, line and polygon. So this is the road. Line feature is nothing but the road feature, where you are having number of points together joined, and then the point is nothing but having XY location, and here it is a polygon. Okay, the surface is segregated into number of layers, but whereas the surface is classified as a pixels, or we can call as a grids. So both the having information but in a different formats. The representation is here is a raster format, it is a vector format. Raster format means image format. We are depicting the information in the form of an image, or sometimes you can call it as a pixel or pixel elements, or sometimes dot per densities, whatever it is. So all the DN values or the pixel values will have a DN value. DN value will vary from 0 to 255. But here it is nothing but a CAD kind of diagram, where you will have a XY location for each and every point. So this is how you will define the spatial data. There are two types. One is the raster type, which is called as image. Second one is called as the raster type, which is called as the vector type, which is called as the image. So vector one will have a three types of features, which are called as discrete points, called as line, point and polygon, whereas the raster is a regularly spaced grid cells in a specific sequence. The individual the cell is called as the pixel, and then each pixel will have the values which is defining in the imagery formats. Now as I told in the beginning of the lecture, GIS deals with the spatial data. Okay, so to make a spatial data, what we require is we need to have the location details, whether it is a XY or XYZ or XYZT. So whatever the fashion, minimum is XY. XY means latitude and longitude. And then the attribute data, non-spatial data, what we call them is a secondary data or the additional details of the spatial data where we are going to explicitly tag with the spatial data which qualifies the attributes. So that is called as the non-spatial data, or sometimes we can call as attribute data, or sometimes we can also call as a secondary data. So this data is always useful for the analysis, modeling, etc. But this is the front end of your application where you will showcase your road information, point information, polygon information. Now, let us come back to the actual the analysis part. Analysis part is nothing but we are analyzing the data, we are imposing the rules and regulations to retrieve the data for your requirements. Say for example, I want to just retrieve all the hospitals in the Hyderabad which are having the blood bank facilities. I don't want to see all the hospitals. Okay, hospitals are many, but having the blood bank facility which are having the hospitals, you know, all it is a standard SQL query. But in the given spatial environment, I need to see only these hospitals which are having the blood bank facility within a given polygon, within a given proximity, because I want to reach to the hospital very fast. So for that kind of analysis, the GIS or the spatial data will have the information such as you can retrieve the information, you can classify. Classification means nothing but retrieval on the basis of a requirement. And then overlaying operations you can do. Suppose you have many layers. Sir. We have overlaying operations. So when you have a retrieval, you will do only a single layer. Suppose hospital is a single layer. So I am just retrieving selecting all the points, all the hospitals having the blood bank records. But here it is different. Multiple layers I am classifying. Multiple layers I am trying to overlay. That means multiple tables. When I have some different tables, multiple tables, so all the tables I am querying at a time or overlaying at a time and then doing the analysis for the sake of my algorithm. Neighborhood operations. Neighborhood operations nothing but when you have a adjacent the boundaries, adjacent the polygons. So they are called as the boundary sharing the polygons. So those also is possible to have. Then next one is connectivity. Connectivity is nothing but we have multiple road network, transport network, rail network. So the network operations we can perform the analysis. So nodes, arcs, so all these analysis are very much. So all are possible in the DBMS. Okay, in the database management system, everything is possible. But only what is new in this domain is we are trying to impose the spatial data restrictions, rules, regulations. In the DBMS, traditional DBMS, we are dealing with only the tables. But whereas in this spatial data, we are trying to explore more on the location and then the spatial features such as the point, line and the polygon. So that is what the extra advantage, and also the projection also we are going to impose. Projection is nothing but the surface details about the geographic details of the surface in the database. Is it okay? Oh, we are following. If any questions also you can raise in between. We will go slowly. I want to take very slow so that everybody will understand. If any questions in between, you can just interrupt me and then we can discuss. Discussion point will give more the details rather than going in a 1 minute. Okay.
Sir, regarding this raster and vector representation, in vector representation you use like line, point and polygon. So which type of representation will be very useful for analyzing the satellite images?
So the point is there are two models, spatial model. You have a raster model, vector model. So the utility point of view, when you want to do the analysis very quickly, okay, on a large area. Suppose entire Hyderabad you want to study the rainfall pattern. Okay. So that kind of operations in a continuous way, the raster operations are more suitable. For example, you want to study the rainfall distribution of the entire Hyderabad. Okay, we have rainfall at yesterday, some particular time. So if you capture that data, you want to classify the rainfall in a different clusters. Which cluster is having the different intensity. So that way raster is more important. But whereas geospatial operations such as connectivity, okay, and then some sort of point oriented information, the vector one is more suitable. But vector one requirements are, you need to delineate this, digitize these things.
So
Okay.
can I consider it as continuous in the sense I can go for raster if it is a discrete? So like
Discrete, that's what here the definition itself, if you try to see, I have made this I have written here, vector model uses discrete points. For discrete analysis, this model is better. For continuous and faster one, suppose you have acquired your satellite data today. Immediately you want to produce results in the same day and with minimum information. This one is more suitable. The reason is interaction is more easy in the raster one because each grid is a unique value. You will have a unique value cell. But here, whereas it is a discrete point, you do not have the entire coverage of the area for this particular. Only the point details are available. Without that, nothing is there. Okay. So now, I will try to explain these four operations, how these operations are performed in the GIS and then the data analysis. Now, the data retrieval is simple a select statement in the DBMS. Okay, but the only thing is you are handling the complete spatial feature and then you are handling the attributes as well, both spatial feature as well as the attributes. Okay, so just see this line. The spatial retrieval is involving the spatial data as well as the attribute value. Attribute value is nothing but your secondary data. Suppose the college is having a spatial feature as a 1 point, okay, on the earth. The corresponding non-spatial data such as number of faculty, number of students, okay, the alumni details, all these things will come as a non-spatial data. Okay, so this kind of thing is very much easy from the data selection as well as suppose I want to find out in Vidya Jyoti College how many students from CSE in 2023. Okay, selection is select all the records of a college where area equal to two conditions 2023, sorry, the year is 2023 and the branch is CSE. Okay, I am combining two conditions. So these two conditions are applied in the attribute values. Okay, the corresponding the results are given into the spatial feature as a whole as a college. So two things I am combining, so spatial feature as well as the non-spatial feature, and then simply the condition is retrieval, simple selection with a multiple conditions. Number 2. Here example is like this. I have given example of so I am retrieving this feature. So this row wise is given here. Similarly, I am retrieving the features by commercial, institutional, recreational, and residential. These are the 4 land use requirements I want. So I am doing the retrieval in the this is what, and then I can also do some measurements between the features. So point to line, and point to polygon. Similarly, vice versa. So all the measurements you can do from the spatial data features from time to time. No. The next one is the overlay operations. Overlay operations basically performed on the more than one layer. So, for example, I have 4 layers. 1, 2, 3, 4. So, I am querying, I am selecting the information from all these 4 layers at a time so that I can get the information and then I can able to select in the present in the